Hello everyone, thank you for joining me. We are going to find the equation of this piecewise function that matches the graph we see in front of us. So this one's going to be a little trickier than some of the other ones because two of the pieces actually touch, but it still counts as one piece, two piece, three pieces. And as we move from left to right on the graph, we're going to move from top to bottom on the function. That is customary to do it this way. Three pieces means I'll need to either write the word if or for 3 times. I don't care if you use if or for, it's completely up to you. And let's find out the linear equations for each piece of this graph. So the first piece, number 1, I need both a slope and a y-intercept. So I find the slope by identifying 2 points and checking the slope out. It looks like we're going down 2 over 1, down 2 over 1. So its slope is going to be negative 2. So negative 2x. And then we also need to either add or subtract a constant to indicate the y-intercept. This piece right here, we cannot actually see where it hits the y-axis or where it would hit the y-axis if it was allowed to keep going. So we use our same slope of down 2 over 1, down 2 over 1, and we track it all the way to negative 8 is where this would hit if it was allowed to keep going. So negative 2x minus 8 for the first piece. All right, we'll do the inequalities at the end. Let's erase this. Second piece is just a little piece of a horizontal line. The only thing we need for that is the number where it hits the y-axis. Looks like it's going to hit at negative 4. You can see that right there, even though it's kind of covered up by the line itself. So negative 4. Done with that piece. Let's do the third piece, then we'll do our inequalities to figure out where each piece is. All right, well, I can tell that it has a slope of 1. Check it out. Up 1 over 1, up 1 over 1, up 1 over 1. It would just keep going. So it has a slope of 1. So you can either write 1x or just x. And then we need to figure out where it would hit the y-axis if it was allowed to keep going. So we use our same slope here, and it looks like this one would hit at 4. So we're going to do x plus 4 there. You can kind of see how it would just keep going and hit 4, but it actually doesn't do that. Okay, let's do the inequalities. Now, the first piece keeps going forever and ever and ever because of this arrow on the end. So it keeps on going down to negative infinity, and it gets all the way up here to negative 2. The question is, does it actually get to negative 2? Well, we're just going to write for starters here, x is less than negative 2. Now you might be thinking, don't we need a equal to there because of the solid point? I'll get to that in just a moment, but let's look at the second one first. It's between negative 2 and 3. So we're going to write negative 2 and 3 like that. Now here's the deal, everyone. You get to pick which function or which piece of the piecewise function gets the equal to, but only one of them can have it. So everyone watch the equation over here. You can either put the equal to on this piece and not on the other piece, or you are more than welcome to put it on just that piece. But only one of them can get the equal to, and one of them has to have the equal to. But it is completely up to you which one you want it on. So on this one, or on this one. I'll just leave it there for now. And 3 is not going to get one. This 3 right here doesn't get one because of the hollow point down here. Last piece picks up at 3 and goes on forever. It does have a solid point, so it's 3 and every number bigger than 3, which we write as x is greater than or equal to 3. And we'll call this one done. Thank you for watching.